Greetings and welcome. Today we'll learn the construction of geometrical figures, and we'll construct these things only by using ruler and compass. We'll learn construction of a given angle. If an angle is given, we have to reproduce or replicate that angle in this video. And we'll also learn the bisection of a given angle, how an angle can be divided into two equal parts, and construction of 90-degree angle, 60-degree angle, 45-degree, 30-degree, etc. All this can be done with the help of ruler and compass only. How a line can be bisected by another line. Then construction of perpendicular bisector of a line segment. Also construction of parallel lines. A line is given and we have to draw a line parallel to the given line. Construction of quadrilateral parallelogram, then rectangles, squares, etc. These things we will learn in our successive videos. The basic instrument required for construction of any geometrical figure is a pencil, and next comes the ruler. And today we'll learn how to construct geometrical figures with the help of a ruler and a compass, and of course with the help of a pencil. So construction using ruler and compasses only. There are other instruments also, like a protractor and a set square. These are called the set square, and this is called 45-degree set square, and this is called 30-degree, 60-degree set square, because it has this angle is 30-degree and this angle is 60-degree, and here both these angles are 45-degree, 45-degree. Now the prerequisites to construct geometrical figures. What knowledge or skills you should have. The knowledge and skills of use of ruler, compass and protractor. You have already learned and developed some skills of using a ruler, compass and protractor, and that you have to apply in these construction exercises. Then comes why we should learn geometrical construction. What are the applications of geometrical construction? Geometrical construction has many real-life applications, and other than that, in computer graphics, the knowledge of geometrical construction is very essential. And if you are thinking of pursuing engineering education in the future, then in the first year engineering courses, there is a subject called engineering graphics or engineering drawing. And in this subject, there is a separate chapter itself on geometrical constructions, and all engineering graphics is based on geometrical construction, and that is the application of geometrical construction that you learn or develop the skill here. Whatever construction we do, it should be an accurate one. The accuracy of a construction depends on many factors, but these three factors are important. Good quality instruments, use of good quality geometrical instruments like ruler, pencil, whatever it may be, and the pencil should be sharp pencil, and proper handling of the instruments is another important factor, and that comes under the skill part. Now in this video I will use the virtual instruments only, but you will have to use actual geometrical instrument and practice the construction to develop the required skill. So without any further ado, let's jump into the actual construction. Construction of an angle equal to a given angle. We are given an angle BAC. We have to construct an angle equal to angle BAC. That means we have to reproduce or reconstruct or replicate this angle. Now let us see how it can be done. To do that, first you draw any line. I give the name PQ. You can give any name. So draw a line PQ. Now we will draw an arc taking A as the center, and we'll take any radius. Let us draw that arc. to cut the line AB and AC. And with this same radius, you draw another arc, now taking the center P. So this is another arc with same radius, and this arc cuts the line PQ at a point. Let us give some name to these points. Say this is point D. In line PQ, the point is R, and the arc cuts the line AC, say at point E. Now we will draw another arc taking D as the center, and the radius is equal to the distance DE. With this radius, we will draw another arc. First, take the distance first. This radius we will take, and now with same radius, taking R as the center, we will draw another arc, and this arc cuts the second arc at a point. Suppose the point of intersection is S. Now you join PS and you can extend it to any length. Now this is the angle QPS equal to BAC. That means we have reproduced or reconstruct the angle which is equal to the angle BAC. And you can of course test this with the help of a protractor. You can measure this angle. This angle is 70 degree, and this angle, let us see, this angle is also 70 degree. Number 2 is bisector of an angle. We are given an angle BAC. We have to bisect this angle into two equal angles. So what line can bisect this angle? That means we have to draw the bisector of this angle. Now let us see how it can be done. Now we will take the compass, take A as the center, and we will draw an arc to cut the lines at 2 points, both the lines AC and AB. Suppose the point of intersections are point E and point F. So we get 2 points. Now taking E as the center, and any radius you can take, but that radius should be more than half of distance EF. So let us draw an arc taking E as the center at the middle of the point C and B, and now taking F as the center, taking same radius as the previous one, draw another arc to cut the previous arc at a point. Suppose the point of intersection is G. Now join AG and you can extend it. Now this is the bisector of the angle BAC. So this way we have bisected the angle BAC, and the bisector is line AG. You can measure the angles also. Angle BAC is 49 here. Exact is 48.8 actually, and this angle is 24. So you see, angle BAC is 48.8 degree and angle BAZ is 24.4 degree. That means the line AZ bisected the angle BAC. Now remember, while drawing this arc, we have taken a radius more than half of EF. Why we should take more than half of EF? Because if we take less or equal to half of EF, then these two arcs will never cut each other, and that is why we have to take the radius more than half of EF. So this way we can bisect angles. Now we will draw an angle of 60 degree with the help of a ruler and compass only. So what we have to do, first we will draw a line, say draw a line AB. Next we will draw an arc taking A as the center. So take A as the center and draw an arc of any radius to cut the line AB at a point. Suppose this point is C. Point of intersection is point C. Now take C as the center and same radius, draw another arc to cut the first arc at a point. So the second arc cuts the first arc at a point, and we take the same radius and both the arcs cut at a point, say D. Now join AD and you can extend it to any point. So we join AD and extend it to another point. BAD is the angle which is 60 degree. Now we can check whether it is 60 degree or not. If you measure it with the help of a protractor, you can see the angle is 60 degree. Now we'll bisect this 60 degree angle. Now why we are going to bisect it? Then only we will get an angle of 30 degree. By bisecting an angle of 60 degree, we will get 30 degree angle. So to do that, take C as the center and take any radius, but the radius should be more than half of CD. Then let us draw this, and taking same radius and center D, draw another arc to cut the previous arc at a point. Suppose this point of intersection is E. Now join AE, and this line divides the angle 60 degree. That means we get 30 degree angle. You can measure this. The previous angle was 60 degree and this angle is 30 degree. So this way what we get a 30 degree angle. Now if we need to construct an angle of 15 degree, what we can do? We can divide this 30 degree angle again, or bisect this 30 degree angle, then we will get 15 degree angle. Then if we again divide that 15 degree angle, then we will get an angle of 15 divided by 2, that means 7.5 degree angle also we can draw. Now we will construct a 90 degree angle with the help of a ruler and compass only. So first you draw a line and give it a name, say the line is AB. Now we will draw an arc taking A as the center and any radius you can draw this arc, and this should be a long arc actually. Suppose this arc cuts the line AB at a point C. Now take C as the center and same radius, construct another arc to cut the previous arc at a point. And suppose this point of intersection is D. Now take D as the center and same radius as the previous radius, draw another arc to cut the first arc at another point. So we get another point, that is point of intersection is E. Now we get 2 points, point D and point E. Now take point D as the center and draw an arc, and the radius of the arc should be more than half of ED. Let us draw the arc. So this is the arc. The radius is more than half of ED. And now take E as the center and same radius as the previous one. Draw another arc to cut the previous arc at a point. And suppose the point of intersection is point F. Now once we get this point, now we can join point F and A. You can join point A and F. This is the 90 degree angle. You can measure this. You see this angle is 90 degree. So this way we can construct a 90 degree angle. Now what if we have to construct a 45 degree angle with the help of a ruler and compass only? then definitely what we will do, we will divide 90-degree angle, and that way we can get a 45-degree angle. So we'll again bisect the angle BAF as explained earlier, and that way we'll get two angles, 45-degree and 45-degree. So we get another point, say H. Now if you join AH, then this angle will be BAH will be 45-degree, because line AH divide the angle or bisect the angle. Let us see what is the angle BAH. This is 45-degree angle. So what we have learned, we have constructed an angle of 90-degree BAF. Then we have bisected this angle by a line AH. So we get another angle that is 45-degree. Now suppose you have to construct an angle that is 22.5-degree, half of 45-degree. Then what you can do, you can bisect this angle 45-degree. You will get another angle which measures 22.5-degree. Now let us solve one question from exercise 18A, and the question is 1, 2. That means second part of question number 1. We are given two angles, angle QPR that is equal to X and angle MLN that is equal to Y. We have to construct an angle X, then Y, and again Y, and that will be equal to X plus twice Y. Now let us see how it can be done. First you draw any line, say line AX. You can give any name to this line. I give the name AX. Now on this line AX, first we will construct an angle equal to QPR. Then again we will construct another angle MLN, and again MLN, and the total angle will be X plus Y, that is X plus twice Y. First take A and construct an arc to cut AX at a point. Say the point of intersection is point B. Now with this same radius, you draw another arc to cut PQ and PR at 2 points, and again same radius, take L as the center to cut the lines of this angle. Now say point of intersections are S and T. So we get a distance ST. Now with this distance as the radius, draw an arc taking B as the center. Remember, this radius is equal to distance ST. So draw this arc and give the point of intersection a name. Say the point of intersection is C. Now we will take this distance from this point O to K. Say this is the point K, and this distance we can take that as a radius of an arc, OK as the radius, and we draw another arc taking C as the center. Suppose this point of intersection is point D. Okay, then taking D as the center, we draw another arc and radius is same, that is equal to OK. So with this radius we draw another arc, and suppose this point of intersection is point E. Now if you join AE, then this angle XAE is equal to this angle QPR plus MLN plus MLN, that is equal to X plus Y. So this is the measure of the angle. You can join AC. This angle is actually angle X, first angle, and if you join AD, then this angle CAD is equal to this angle MLN, that is Y, and the third angle is again equal to Y. You can measure all the angles. You see, this angle was 45 degree, and this angle was, let us say, this is 32 degree. And if you measure whole angle, this is equal to 109 degree. So 45 plus 32 plus 32 is equal to 109 degree. So first we draw the 45 degree angle, then we have drawn the 32 degree angle, then again 32 degree angle, and finally we get an angle 109. That means if this angle is x and this is y, then this whole angle is x plus twice y. So what we have done, we are given angle x and angle y. We can construct an angle of x with the help of a ruler and compass, and also we can construct an angle y. First we draw a line, then we draw an angle of x, this angle, then on this line we draw another angle that is equal to y, this angle, and on this line again we draw another angle that is equal to y. So what we have done, angle x plus angle y plus angle y, so the total angle is x plus twice y. So this way we can construct angle, we can combine the angles, and we can use the method of construction of an angle equal to a given angle. So suppose you have to construct an angle, say I am taking 90 degree plus 30 degree, that is equal to 120 degree. If you have to draw an angle of 120 degree with the help of a ruler and compass, then what you can do, you can construct 90 degree angle, then you can construct a 30 degree angle. To construct a 30 degree angle, you have to construct 60 degree angle, then you have to divide this angle. So this way you can get 120 degree. And suppose you have to draw an angle of 90 degree plus 45 degree, that also you can do. These are the combinations of 45 degree and 90 degree. Suppose you have to draw an angle of 60 plus 45 degree, that is equal to 105 degree. So all these angles we can construct with the help of a ruler and compass. These are only the combinations of these angles, 90 degree, then 60 degree, then 30 degree, then 45 degree, then half of 30 you can get 15, half of 15 you can get 7.5, this is 22.5, and so on. So you can get any numbers of angles. In the next video we'll discuss about bisector of a line segment. We learn how to draw a bisector of a line segment, or how to bisect a line segment. So till then, thank you.